This is the second video in a 4-part series providing a basic introduction to the new Nexus 2 Matlab interaction capabilities. In our first video, we did a really brief introduction to how you go about linking up these two packages, and in this video we're going to go a little bit more in depth and we're going to look at how you can extract trajectory data from your Open Nexus trial and then also create a virtual marker and put it back into the open trial. So as you can see, I have a running trial open. This is the same one from the first video. And if I go into Matlab, I have my editor window up at the top here and my command window down here. So I've pre-written the script this time to make it a bit more, I suppose, time efficient to save me typing it as I go. But I'll run through each of the commands and explain them. So the first one that we have is obviously this vicon equals Vicon Nexus. Now again, we used this in the first video. It's really important to do this before you do anything else because this is what is going to establish the link between Nexus 2 and Matlab. So I'm going to run this line of code here, and what we'll see is in our workspace we have Vicon has appeared here. So now we can go on and start using some of the inbuilt commands, like GetSubjectNames, for example, which we also used in the first video. So if I run this command now, and we go up to the workspace again, we can click on subject name and we see that John Smith has appeared here, so that's our subject name. And now what we want to do is create a virtual marker that is the midpoint of two of the thigh markers. So we have the right thigh cluster here, and this is RTH1, right thigh 1, and this is RTH3, or right thigh 3. And what we want to do now is import both of those marker trajectories into Matlab, and then find the midpoint of those marker trajectories, and then take that midpoint and create a virtual marker in Nexus representing the midpoint. So what we're going to do is use the GetTrajectory function to achieve that, to first import these trajectories. So we're going to go vicon.GetTrajectory. This command requires two input parameters. So firstly we have the subject name, and then secondly we have the marker name that we want to import. So what we have to set up in terms of output, well, we have the trajectory data, so we have the three components that we're typically used to seeing, the X, Y, and Z planes. And then we also have E, and E represents whether there is data in that frame or not, so it's whether data exists or not. And so what I've done here is I've got a marker RTH1. RTH1 is going to be my variable name. And then for X, X is going to be placed into all the rows of column 1. Y is going to be placed into all the rows of column 2. Z into all the rows of column 3. And finally, we're going to place the exists array into all the rows of column 4. And then we're going to do the same thing for right thigh 3, except for this time we're calling it RTH3. And you can see I've had to change what the marker name that I'm bringing in is down here. So if I run both of these, we'll take a look at the output. So I've run both of these now, and I go into my workspace, and I've got RTH1 and RTH3 have been added to my workspace. And if I click on one of them, you can see that this column here is the X data. This is the Y data, this is the Z data, and then this column is your exists column. So you can see where there is no data, there's zeros in the exists column, and this is actually because, I mean, when you talk about exists, 0 represents false and 1 is representing true. And so in the case of this marker here, you can see that the data actually starts at frame number 26. And if I go into my Nexus trial, you can see that the actual trial has been cropped to start at frame number 26. So this is correct. And where data exists, you see that there's a 1 in this column here. So what I can do now is come back in here and I have my two markers set up with their x, y, and z components. So now I want to find the midpoint of that, which I'm assigning to the variable RTHMid. So I've just called that RTHMid here. And what I want to do is create a virtual marker that's halfway between. So if I run this, you can see that it's got right thigh 1, and we're only using columns 1 to 3 because that's the data we're interested in. And we won't need to do that to the exist column. Obviously, we're just creating a marker that is the midpoint. So we'll work out whether data exists or not in the next line. But for now, if I run this, RTHMid comes up here. And what I've done, you'll notice, is that I've converted, instead of having 3 columns, I now have 3 rows. So row 1 is X, Y, and Z. And how I did that was I transposed the matrices before using apostrophe. So apostrophe will transpose. And the reason I did this is because when you're bringing in data into Nexus, it prefers to be in this format here. So you need to have it in 3 rows as opposed to 3 columns. So it's just a simple transpose, and you can see all the data is in there. And then to get the exists matrix here, we go and what I'm doing is I'm saying, okay, what is the minimum of the current column, the 4th column of these two variables. And obviously, in the case that they're both 1, then so there's data for both of them, then it will produce, so 1 is the minimum. If they're both 0, it will produce 0. But this is also good because in the case that one of them is 0 and one of them is 1, obviously there can't be data for our midpoint. So in that case, it has to treat it as data does not exist. So we're relying on the minimum. But one thing to note about these exists matrices is that they have to be logical. They can't just be a numerical matrix, they have to be a logical matrix, hence why I've created a logical matrix here. So it just takes anything that is 1 and it calls it true, and anything that is 0 and it will represent that with false. So if I just run this line of text here, and now I go into my workspace, you can see that it's been saved as a logical variable here. Now the next 2 lines, when you run them, nothing happens, but basically, no outputs will be displayed in your workspace because you're not saving this to a variable. Now you're starting to work within Nexus. So the first one is to create a modeled output. And this command requires the subject name as the first input, the name that you intend to call the new marker, so in this case RTHMid is the name that we want to choose, and then for the group of the markers that it's going into, obviously if you had, say, some angle data or something, you put it in angles, and we're calling this one modeled markers. And modeled markers will allow a marker to be created within the 3D space. So if you call it modeled markers, just like that. And then you've got your 3 components. You've got X, Y, and Z. So that's your components in here, the names of the components. Note the curly brackets at either side of this. And then finally, you've got these 3 component types. So you've got the component type for each of these, which is basically just how Nexus will display this marker when you graph it. So say, for example, if you've got an angle instead of a length, you're going to get your graphs displayed in degrees. Length is going to show us millimeters. So we're going to use length today because we're looking at the position in the X, Y, and Z planes of the global coordinate system. And then down here, after we've created the model output, we've actually got to set the model output. So basically, if I run this now, firstly, let's go into Nexus and have a look at our model outputs. So if I run this, what we should see is if I come back in here, I now have one called model markers. And model markers has this in it, but this is currently empty, there's no data. So all this has done is create a model output with the name RTHMid, But to actually populate that with the data that we've created for RTHMid, which is this, and its exists is relevant too, we've actually got to set the model output. And the input that we need for that is subject name again, the marker name that you're going to use. You've got to have the data that you prepared, so obviously the midpoint data, and then your exists matrix. So if I now run this one, what you might have noticed is that a very small marker, virtual, has appeared in this space here. And it is the midpoint of RTH1 and RTH3. And if I just hover over it there, click on that, and graph it, you can see it has X, Y, and Z components across the whole trial. So that's basically how you brought in this marker, how you extract these two trajectories, how you can manipulate that in Matlab, and then how you can export it from Matlab as a virtual marker and back into Nexus. So now we're just going to do one more thing before we finish up. I'm going to explain that if you are in Nexus, just close that second. So we're back in Nexus. What we could have done is once you prepared a script in your editor in Matlab, so this is a script called part 2, and if I just save that there and come out of Nexus, you might notice that there's a Matlab tab in Nexus. So I click on the Matlab tab, and basically I need to, in this line here, locate that script file that I just made. So if I go into my Z drive, I locate the file that I just made, and it should just come up in a second. Brilliant. And then that's the file I've made, so it becomes available here. Script arguments, well, for this one I didn't have any, so I don't need any script arguments. And then what you could do is you could actually run the script this way. So I could completely close Matlab and I could just add the script in here and run the script through this channel here. So that's also an option for you. So if I hit run script now, it would just do the same thing. The other option is to create a pipeline, and this is even more efficient because it means that you can then batch process your data. So if I go create pipeline, and now I've got to go into tools, you can see here that it's created a pipeline called part 2 because that's the name of the M file that I just saved my trial as. And you've got the script file location, and then all you would do is you would save this as, and you could call it perhaps part 2 as well if you like, and save that, and now you can batch process using that script. So that there just provides a basic another basic introduction into how you might take out trajectory data, manipulate it, and create a virtual marker.